An arrangement of all the known elements according to their properties so that similar elements, same vertical column and dissimilar. Let us look at the periodic table of elements. We start at the top with hydrogen. See here, these halogens, they are very reactive, always looking for love. Let us look at the periodic table of elements. We start at the top with hydrogen, a non-metal. Next is helium, a noble. Dobereiner's law of triads, Newland's law of octaves, Mendeleev's periodic table, modern periodic table. Dobereiner's law of triads explains slowly. He grouped elements like chlorine, bromine and iodine. Their average weight is close to bromines. In 1829, Dobereiner arranged the known elements of a time the ascending order atomic called triad. In 1829, Dobereiner arranged the known elements of at that time in the ascending order of atomic masses. Good morning, students. Today, we will learn about Dobereiner's triads. Observe the table. Notice the patterns. Hello friends, let's talk about Newland's law of octave. He arranged elements by properties, making science easier for us. In 1865, Newland arranged all the known elements of at that time in the ascending order of atomic masses. Hello students, today we learn about John Newland's law of octaves. Look at this in form of perf interlaces interforaminant. So this is law of octaves, a key to the periodic table. Hello students, today we learn about John Newland's law of octaves. Look at lithium and sodium, they are in the same group. Mendeleev's periodic law. The law states that the physical and chemical properties of elements, gallium and germanium, were unknown at the time Mendeleev published his periodic table. He called these elements Eka aluminum and Eka silicon. We begin with the periodic table. The first row, hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and helium. Good morning students. Today we will learn about the modern classification of elements. In the modern periodic table, elements are classified into 4 blocks. Classically use the orbital host. S block elements are elements where the last electron enters the s orbital. Their configuration is ns1 or 2. Hello students, today we learn s block elements very slowly, starting with hydrogen H, lithium Li in period 2. Hello students, today we learn s block elements very slowly. These are group 2 elements, very reactive: beryllium, magnesium, calcium, strontium, barium, radium. P block elements. The elements in which the last electron enters the p orbitals of their valence shell are called p block elements. Hello everyone. Today let's look at the p block elements from group 13 to 18. These include metals, metalloids and non-metals like the noble gases. The elements in which the last electron enters the d orbitals are called d block elements. Hello students. Today we study d block elements. I will use this pen correctly to show you. Starting from scandium, titanium, vanadium, the elements in which the last electron enters the f orbitals are called f block elements at ns2. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Hello students. Today we will learn about types of elements. There are metals, non-metals and metalloids. The elements of the 18th group are called noble gases or rare gases. The d block elements, that is elements of group 312, are called transition elements. They are placed in between s and p block elements. The f block elements are called inner transition elements. It consists of coming after lanthanum are called lactanides.